machine itself. Journal bearings can be more difficult to replace than other types of journal bearings. Frequently, they must be slipped on and off the end of the shaft, or the shaft must be worked through the bearing. Journal bearings typically consist of a metal sleeve that fits around the shaft. The sleeve is held in place within a housing. The journal is simply placed on the shaft and is grounded and supported by the bearing. Journal bearings can be made out of metallic or non-metallic materials.
So please mute your microphones. So let us go for one more diagram related to that journal bearing. So now this is a journal bearing. So here, so we have a bearing housing here. So we have a lubricant out, lubricant in. So lubricant in is provided at the top, and you have a bronze bearing, and you have a journal. Okay? So it is an example as you've done plumber block in computer aided machine drawing. So plumber block is an accessory to fit a journal bearing. Now, if you consider the parameters here, so outside is the housing. After housing, you are going to fit the bearing here. That is what a bronze bearing. Next one is a journal. Journal means it is just like a shaft. That is what a rotating member. So in between, you have a clearance. So this clearance is provided with the lubricant here. That is going to contain the lubricant. Now, if you look out, so L is what? Length of the journal. D is diameter of the journal. N is speed here. N is speed. Now, you can find out the journal diameter as well as the bearing diameter. So, once you calculate the required journal diameter. Okay. Now, let us go for some procedure. We'll go for procedure now. It is what design of journal bearings. Now, in last class, we come across classification of journals. That is what based on load as well as based on the contact. Then you have come across the bearing materials, and we have gone for some tables so where you can get the data. So for designing of journal bearings. Now we come across one more. That is what Petrov's equation. So Petrov's equations to find out the coefficient of friction and get the torque as well as frictional force. So now we'll go for a design of design procedure for journal bearings. So you're going to get a 10 steps here. You're going to get a 10 steps. So design of design procedure for journal bearings. So now the first step is you need to find out the data. So based on given problem definition. Okay. So now for the given type of bearing as well as the machine, so select the recommended data. So first one is step is what you need to select recommended data. So from design data handbook, That is what referring table number 15.7. 15.7. So we had a data. So like the pressure, the clearance ratio, the bearing modulus number, as well as the diameter to length to diameter ratio. Now in step 2, you need to find the journal diameter here. Find journal diameter. Once you got the journal diameter, so then you need to calculate the length of journal here. Length of journal, that is what is L. Now after this one, you need to check the pressure intensity. You need to check pressure intensity. So that is what the actual pressure is going to occur over the lubricant. Now third step, you need to select the oil. You need to select the oil from design data handbook, referring figure number 11 point, sorry, 15.3 here. So once you got the oil, now based on the parameters of the oil, you need to calculate what is the absolute viscosity. Then once you got the absolute viscosity, you need to check for the bearing modulus number here. That is what in step 4, check for suitability of oil. Check for suitability of oil. Now, as I said, in this case, you need to recalculate bearing modulus. And bearing modulus, what happens? You're going to get a value of K or C. That is what by calculation of Zn by P. Now you need to compare this one. You need to for comparison. Okay. So with values, that is what now it has to be for hydrodynamic lubrication, for fluid film lubrication, as well as thick film lubrication. Just you need to go for comparison. Okay. Suppose if the value of K calculated is greater than value of K recommended. Okay. So then selected oil is safe. Suppose if calculated value of K is less than the value of recommended, then you need to change the oil here. You need to change the oil. Now in step 5, you need to calculate the coefficient of friction here. Coefficient of friction, F. So we have a formula from data handbook. You just select the data handbook and notify the formula. Once you got the coefficient of friction, then you will calculate the heat generated. Calculate heat generated. In next step, you need to calculate the heat dissipated. You need to calculate heat dissipated. In next step, so you need to calculate power loss. Power loss in the bearing. So due to friction, due to friction. So next step, you need to find out the minimum film thickness here. Minimum oil film thickness. And the last step, you need to find out flow rate of oil. Flow rate of oil. So for every step, you have a formula. So you need to select those formulas. Okay. Now I'll stop here. Some of you are raising questions. Uh, it is better to upload the videos in YouTube. So I request you to raise or quote your answer in chat. Whether it is better to take online class or whether it is better to go for offline class. Chat box is open. Just chat. So most of you are suggesting that YouTube best search. But when I look into data about the YouTube, the watching time is less than 1 minute of every video, and hardly 25 to 30% are going to give. The rest of you are not viewing it or watching it. Now, if this is a situation, it's a difficulty to get the content. So some of you have suggested go for online classes, sir, and upload the same video in YouTube. We'll go for that one. And for numericals, you need the parallel calculations because when you've done one problem in YouTube, you did some mistakes there. To overcome those mistakes, it's better to draw parallel. Means to better go in a parallel way. Everyone have a calculator. I suggest to have a calculator, pen, and all those things. Either say yes or no in chat box. Okay. So those who have calculator, you just try to solve parallel, and those who are not have a calculator, you just watch and notify the data. I go for sharing my desktop again. So now I'll go for problem here. So the problem is design main bearing of a 4-stroke diesel engine to sustain a load of 6 kilonewton the operating speed of the shaft is 1000 rpm. Now let us notify first given data here. So engine is what? It is a 4-stroke diesel engine. Next, load is given, that is what W, it is 6 kilonewton, and speed is specified here. Speed is 1000 rpm. Now, based on this, we'll go for selecting the data from table number 15, from table number 15.1.
Table number one.
Now, the data are the maximum pressure and minimum pressure here. maximum and minimum pressure that is going to occur in an bearing is 4.8 megapascal to 8.2 megapascal. Next, the absolute viscosity Z that is from 0.0202 to 0.065 so Newton second per meter. Next, the minimum value of bearing modulus got Zn by P, it is 2.9. The clearance ratio where your video is back. So now clearance ratio is 4.001 watts by R and the bearing ratio what L might be the 0.62. Now whether sound is clear or is tracking the 12 mark. Now let us go for calculation of pressure and we need to find out the dimension.
Audio clear is this.
So now let us go for calculation. I think audio is now clear. I think audio is clear now. Okay. So now data has been noted from your data handbook. Okay. So data is what? So I have noted in the previous slide, that is what the maximum pressure, absolute viscosity, varying modulus, and fluency. So first step is you need to find out the dimensions. So here are the dimensions. You need pressure. Now load is given. Load is given. Now load by area, it will be the pressure. Now to get the pressure, so to get the pressure, let us go for the calculation of pressure. Now to get the pressure, either you go for average of both the values, or you can just take a maximum value and average it. So what are pressure were noted here? Range pressure range is, so it is 4.8 megapascal to 8.2 megapascal. Right? Now for calculation purpose or for design purpose, you can go for average of 4.8 plus 8.2 divided by 2. So plus 13 by 2, 6.5 megapascal. For you can go for average of maximum. You can go for 4.1 megapascal. Right? Now what we'll do? We'll go for 6.5 megapascal. We'll go for 6.5 megapascal. Now you got the pressure. Actually, you better go in area. Now I will clear. I think I will clear. Sir, please check it again. Audio is not clear. Sagar, now audio is clear.
Yes, sir. Clear is.
Right. Now what you got? You got a pressure. Next thing is you need to go for the dimensions here. Now you have noted bearing ratio. You have noted bearing ratio. So bearing ratio is 0.62 here. That is what? So L by D 0.62. We can select 2 times. Now we'll go for L by D as 0.6 plus 2 divided by 2. So much? 1.3. That means the length of journal L is 1.3 times of diameter of journal here. 1.3 times of diameter here. Now what you noted? You have noted bearing pressure. Now based on the bearing pressure, this is what P equal to W divided by LD. W divided by LD. So now substitute L in terms of D here. Now what will get? It is 6.5 is the pressure. 6 kilonewton is the load. L is 1.3 D and you have a D. Now you calculate what is the value of D square. Then you calculate what is the value of D. Okay. Now approximately we are going to get 26.65 mm as the diameter of journal. You go for higher value, D equal to 27 mm. So you have a 2 minutes, you just cross check whether the diameter of journal is 27 mm or not. Okay, right. So we'll go for approximately 27 mm. Okay, thank you. for your answers. Now let us go for the length of bearing here. So length of bearing L equal to what? 1.3D. L equal to 1.3D. So now 1.3 into 27. Now it is around about 34.35.1 mm. So let us go for L equal to 35 mm. Now how much? D equal to 27 mm. L equal to 35 mm. Now based on the dimensions what you got, you need to check out what is the actual pressure you are going to get here. Actual pressure is what? W divided by L. W is 6 kilonewton. So L is 35 mm. Diameter is 27. Now we calculate it is 6.34 or 35 megapascal. Right? So now P actual it is 6.35 megapascal. So I'll stop here. So we'll continue at 12 o'clock if possible because we have a meeting with the HOD sir.